Hello and welcome once again. In the following video, we will perform a hands-on lab on static NAT and static PAT. But before jumping into the lab, let's have a quick review on the topic. The next type of NAT you will see more common is the static NAT. This type of NAT is mapped one-to-one, meaning one single public IP with all of its IP protocol numbers, TCP and UDP included will be mapped to one single private IP address. Static PAT is the better and scalable version of static NAT as it maps port numbers alongside IP addresses for one-to-one mappings. This is often referred in the industry as port forwarding. Now, static NAT or static PAT are typically used when you are hosting some sort of service in your private network and you need it to be accessible from anywhere on the public network. The most common example of that would be if you have installed IP cameras in your home and you need to access them from anywhere via the internet. In the description of the video, I have timestamps, so if you want to go to a certain part of the tutorial, you can click on the timestamp and it will go directly to that part of the tutorial. And if I go too fast or too slow for you, you can adjust the speed of the video over here. If you have any questions or feedback, feel free to leave a comment below this video. Let's get started. Hello and welcome to the second lab of the series. Today we will be performing static NAT and static PAT, or port address translation, which is more commonly referred in the industry as port forwarding. This lab is going to be performed on Packet Tracer, and the same lab will be available in the description, or if you're watching this on our website, it will be available in the downloads area. Now, in the previous lab of NAT overload, we were accessing Dr. Network's website as a client. Now we're going to be hosting that same web server in our premises behind a NAT router. Now, just to give you an overview of the lab setup that we have here, we have Dr. Network's HQ, which is headquarters. Here on the left side, we have our NAT router, which is unconfigured in terms of NAT. Only IP addresses have been configured on this. And then we have a switch, which has all of its ports in VLAN 1, and they're all access ports. We have PC0. I should have named it PC1A or B something, but it's the default name of the PC. So I didn't really change the name. So it's PC0 that is just acting as a client in Dr. Network's HQ. And then we have Dr. Networks.net web server sitting inside our organization. Now in the middle, we have our ISP, or Internet Service Provider. We're kind of like emulating this internet again as we were in the previous lab. And this is just an icon that I told you before in the previous lab, that we have icons that we're going to be using. And in the backend, it's only one router, which has 3 interfaces, public interfaces. And in the real life, obviously, it's not going to be the same. So you're not going to have this Google DNS server literally just, like directly connected to the internet. It's going to be like this network, Dr. Network's HQ environment. Even more secure than that, because they're going to have firewalls and stuff. But again, we're just emulating an ISP or internet, you could say, here in our lab topology. Now, the Google DNS or web server that we have in our environment is running DNS services and web services. So if you try to access it via google.com, the Google page should come up. And if you try to resolve the domain names that we have in our environment, which are google.com and drnetworks.net, this is the DNS server that's gonna do that in this lab. We don't have any other DNS server in this lab. We only have one, and that is the Google DNS server. Now on the right side, we have a home network. Just like in your homes, you have these modems which have built-in wireless interfaces, and you could wirelessly connect to those interfaces via your laptop or your Android device or any device, and you can access the internet. So we're trying to like emulate a user that is sitting on the laptop in its home and is trying to access docternetworks.net. Now, without further ado, let's just jump into the lab guidelines and start configuring stuff. Now, lab guidance state that define the inside and outside NAT interfaces on the NAT router. That's pretty simple. We have this NAT router which has two interfaces, gig 0/0/1 and 0/0/0. This side is configured obviously for the public IP address, and we have one IP address. Basically, we have a subnet that has only two IP addresses. One is configured on our side and one on the ISP side. And we have our inside interface that we're going to be configuring, and that has an IP of 10.1.1.254. So let's go into these interfaces. Now, let me give you a show run output. Now, in the show run, the IP addresses have already been configured. Nothing is configured apart from that. I don't think even the routing is configured. I'm not sure I did that or not. I don't think I did that. Okay. First of all, let's go back and see. Okay, gig 0/0/1, that's going to be IPNAT inside. So interface gig 0/0/1, IPNAT inside. That's pretty easy. You've seen that in the last lab as well. And it's gonna be interface gig 0/0/0 IPNAT outside. So show IPNAT just to verify that. Statistics, yeah. Okay, so we see that outside and inside interfaces have been configured properly. You could just verify from this output if you wanted. Now, the second lab guidance step is that define the static NAT statement for the web server 10.1.1.100. Now, if you look at the statement, it's saying that we have to do static NAT. Now, whenever a static NAT is used, that means that you're going to be doing a full IP stack NAT. Now, in the industry, you will not see this very commonly referred. People will say, do a static NAT, do a static NAT. What in reality, they may be saying that do static PAT. So if somebody is saying do static NAT, that basically means doing a full IP NAT. So let's go and try to do that NAT. First of all, let me see. Okay, this is my private IP address, 10.1.1.100. And that's not my public IP address, but let me just put it this way, 200.1.1.1. This is my public IP address. That is a network ID. So there, that is configured on the gig 0/0/0 interface that is facing the internet. Now, I need to NAT that such that if anyone hits on 200.1.1.1, what I want it to be is that it should be translated to 10.1.1.100. And vice versa, whenever 10.1.1.100 is trying to reach out to the internet or anyone else, its IP should be translated to 200.1.1.1. Remember this, static NATs are bidirectional. Now, this will be cleared more once we have that lab performed. Let me just show you how to do this NAT statement now. Now, going to global configuration mode, doing IPNAT inside source, the same kind of thing that we were doing in the last lab. We were choosing the list with the ACL in it. Source. Now we're going to do static. So we're going to be statically defining the NAT statement. Okay, first of all, it wants me to say, okay, what's the inside local? Now, by this time, you should have a very good understanding what inside local is. And if you're not, this is the inside local in this scenario, 10.1.1.100. So I'm going to say, okay, inside local is 10.1.1.100. And it's going to say, okay, what's the inside global, the global IP address? And that's going to be 200.1.1.1. So, oops, 200.1.1.1. Now, there isn't really much. That's pretty simple. If you look at it, it's pretty simple if you're doing full IP stack NAT. Now, what happens if I hit enter? First of all, let me show you another thing here. Check that out. You could also choose TCP or UDP here, and that is where things get into port address translation in terms of static NAT. But for now, I just lost my statement there. For now, we're just going to be doing static NAT, pure static NAT. Every IP protocol, TCP, UDP, every port of it is going to be NATed to, if it's hitting 200.1.1.1, it's going to be netted to 10.1.1.100, everything. And vice versa, the other side, if traffic is coming from the inside. There it is. So static NAT is now working, hopefully. Let me show you IP NAT translation. Now, as you can see, this specifies these dashes, and these are indications that it's a static NAT entry. Now, we basically discussed these inside global and inside local. It's pretty straightforward now. It should be. We'll see that in action in just a minute. Okay, so we've configured static NAT, but we haven't really tested anything as of right now. Now, let's jump to my home network right now and see what's happening there. First of all, let me show you the router that we have here, the home router. I'm sorry, it's not D-Link, it's some other brand. I mean, wireless tri-brand band home router. It kind of looks like a D-Link. There is not much that I can show you here, but I could just show you the status of what I have here. So first of all, the connection type that we have, I mean, this connection, this connection that is connected towards the ISP, its connection type is automatic, it's DHCP. So my router that I have actually configured on the ISP side is giving out IP addresses to the home router. In reality, it's pretty much a triple PoE connection. It could be this kind of connection, but mostly it's triple PoE. Well, the internet IP address it got from the ISP was 100.1.1.1, subnet was /30, and the default gateway is 100.1.1.2, which is their ISP's default gateway. And the DNS server that I have configured for this router is 4.2.2.2. Now, just to be really clear right now, every device that you see here that needs DNS resolution is pointing towards 4.2.2.2 in this lab. Now, let me just, okay, sorry about that. I was testing something, I think. Okay, let me just go to the terminal of this laptop and let me see if what's happening with this laptop. First of all, I was just sorry, man, you got me. I was just testing some DNS lookups, so pretend you didn't see that. So ipconfig/all. First of all, I'm going to see the DNS server. It's configured. Obviously, the IP address is configured, and it got it by DHCP. I don't know if it shows that here. Okay, yeah, oh, there it is, DHCP servers. You can see the DHCP servers is specifying from this DHCP I have got this IP address. Now the DNS server is 4.2, and check that out, it's wireless. That's pretty cool. Okay, so we're sitting on this laptop, and what we need to do first of all, what we need to see is that can we resolve google.com to see if we have internet access, and then we're going to be accessing darknetworks.net. Now to test that, first of all, I'm going to do a normal pings will work. First of all, I'm just saying, okay, can I reach 4.2.2? Beautiful, I can do that. That is because I'm being netted by this home router 200.1.1.1. Now to test domain name resolutions, let's first of all do an NS lookup to google.com. Is it resolvable? Pretty much it is. Okay, so that's great. If it's resolvable, I should be able to open my web browser just like I would in a real environment and type in google.com, and bingo, there it is. Google is opening. Now this is not the real Google, it's just an image. I think it's a PNG image or JPEG image. Let me just show you
I don't want to hide things from you. Okay, where is it? Services are running, and there is HTTP, and do an edit. There it is. Just a simple HTML code that is referencing the Google PNG, which I have uploaded. If I look, there it is. There's the Google PNG. So that's pretty much simple. Now, let's see if we can resolve, first of all, our domain of drnetworks.net. drnetworks.net. Beautiful, it can resolve it. Now, before I hit drnetworks.net, let me just do one thing. I want to get rid of that command, no IP NAT inside source static. That is only because I want to show you that I can't reach .NETworks via web services right now. .NETworks.net. So you see the domain is resolved. You can resolve this domain, right? You can actually ping this IP address because it's on the router. I mean, can you ping the IP address? Let me just check that out. Oh, there's a problem there. The problem is that I don't have a default route. Oh, remember the part from lecture 4 that I emphasized so much, that routing goes hand in hand with NAT. So I forgot to actually put the default route here. Okay, so we gotta take care of that real quick. IP route 0.0.0, 200, now 2. All right. Now let's check that laptop again. Let's check that laptop again. It should be pingable now. All right, great. You see that now it's pingable. Now routing is complete. Hopefully it is complete. Now let's do again. Let's try to access .NETworks. .NETworks.net. Server reset connection. Now that is happening because I'm landing on the router. Let me show you. Now this laptop is landing on the router. The router doesn't have a NAT statement, so the router thinks this packet or this web request is for me, for the router, and it says, sorry, I don't have web services running on me as of right now, so I'm sorry, I'm gonna drop that, or I'm gonna reset your connection. Now let's do a static NAT, the same static NAT statement that we were using, and this is IP NAT inside source static 10 and 200. All right, so let's try it again now. I'm sorry I'm going back and forth. I hope you understand all of this. It's not that hard for you to understand, hopefully. Networks, networks.net. Beautiful. Now you see this is the same kind of web server that we were seeing in the previous lab. So welcome to .NETworks website. Now let's see what's happening on the NAT router as of right now. So we'll do a show IP NAT translations, and you can see from this output that 101.101, that is the IP address of this home router, because it's natting the laptop's IP address to a public IP address, and it's hitting my NAT router on 200.1.1.1 with port 80. So that is the basically source IP address in their perspective. So that is where the packet is being initiated. Now, where the packet is initiated, you can see by port numbers. You see port number 80. So you're hosting a server of HTTP and it's on port 80. If you see that on your local side, your inside global or inside local, that means the packet has been generated by someone from the outside. You can also see that from these port numbers that these are not the well-known ports. These are port numbers generated by laptops. So you can pretty much like identify where the packet was initiated from the outside or the inside. Now to clear that out, if I was to go to google.com from my server, For example, if I wanted to go to google.com, let me show you google.com, and hopefully it does the resolution. Uh-oh, it's not working. That's not good at all. First of all, let me check. Oops, that's the DNS server issue. I actually made it a DNS server previously. So let's check it out again. Google.com. So there it is. I can reach google.com now. Now, what I want you to see in the translations is, check that out. Now, as you can see, there's kind of like inverted, isn't it? Let me just clear that out a little bit. Okay, the first two statements that you see are of protocol UDP, and they were basically for DNS resolutions, because I have the DNS server set to 4.2.2.2, and DNS port number is 53. That's a well-known port of DNS. Now, if you look at this entry, this was the previous one. That was, the packet was initiated from outside, and this is the packet that we just initiated from the inside, the web services that we were using. Remember, I told you that 4.2.2 in my lab is hosting two services, DNS and HTTP. These are both the services running on my web server, on my Google server. So I have HTTP services running and I have DNS services running. So both are on. Now, as you can see, by looking at these translations, you can identify where the packet actually initiated from. Did it initiate from the outside, or did it initiate from the inside? So you can have that clarity by just looking at these translations if you needed to. Now, by IP NAT, what did we mean? By IP NAT, we meant that anything, any IP protocol that was coming in will be natted to that private IP address. Now, let me show you this. Let me just do a ping now. I was doing a ping previously to this guy, and let me just hit that and dash T. Oh, there is no dash T. There gotta be something. Okay, whatever the case may be. Now look at that. Now even the pings you will see are being natted. Well, it shouldn't be, right? Means if I try to telnet this router on 200.1.1.1, it's gonna be natted and translated to 10.1.100, and the packet goes to .network.net. That's not good, because I only have one public IP address, right? So what happens with these guys? Well, that's a problem, because you have utilized that public IP address fully with all of its IP protocol numbers, this guy won't get internet access anymore. And everything that is coming to this IP address will be added to this guy. Now that is where the static PAT comes in. Static PAT utilizes port numbers instead of utilizing the full IP protocol stack. So the next step is removing the NAT statement of that static NAT. First of all, we'll do that. No IP NAT inside. Let me just do a show run. Let me show you. There is a statement of static NAT. Copy that. No. Paste it there. And now we're going to be using static PAT. We have only web services running on drnetworks.net, right? So I don't need to NAT the full IP protocol stack for one web server, right? Doesn't make sense. That is why port forwarding or static PAT is very popular in the industry. So how do you configure that? You configure this by saying, oh, sorry, just configured static NAT again. Oops. Okay, I'll do it. Okay, I've just unconfigured it. Now it's time to static NAT TCP, because port 80, our HTTP, works on TCP. So now the inside local is the same. What's the port number? It's port 80. And What's the global IP address? It's 200.1.1.1. Now, normally we would just put port 80 here, and that's it. That's pretty much it. That's pretty understandable statement. So this is the port number and the IP address on the inside, and this is the port number and IP address on the outside. Now you might be thinking, why do we have to specify them on two parts? Like why on inside local and also on inside global? Well, that is because there could be a case where you may have two web services running inside of your network. In that case, you would have to change the port on the outside to something else. Now this is gonna be confusing, so I'm not gonna touch that. So the thing is that we will discuss this in the future series and how do we do that. So it could get really complex, but I'm just telling you why it's asking us to specify these port numbers. Now in our lab, we only have one web server, so we can keep the port 80 on the inside and keep the port 80 on the outside. Now let's do a verification again. Well, first of all, let me just do a ping, and pings are happening. Now let's check if there are any IP NAT translations. Show IP NAT translations? No, because we're only listening for port 80 now. So if that's the case, I would have to go into my desktop and my web browser and open up drnetworks.net. Beautiful. It's opening now. And only the translation for port 80 is happening now. So it's pretty justified now. All right. So that's pretty much it for the lab, I think. The last bit of information that I would like to give you is that now you can use NAT overload alongside this static PAT. All right, so it will work. So you can have your internet services running alongside this static NAT. And this is the assignment. I will leave it for you guys. I hope this has been informative for you, and I'd like to thank you for viewing.